We're on problem 55. 55. At a certain picnic, each of the guests was served either a single scoop or a double scoop of ice cream. How many of the guests were served a double scoop of ice cream? So let's say that D is the number of guests that were served double scoop, and that's what we're trying to figure out. So what are their statements? Statement number 1 says, at the picnic, 60% of the guests were served a double scoop of ice cream. So 60% of the total were served double scoop. Let's see if we can write that algebraically. So 60% of the guests. So 60% of the guests. So the guests, the total number of guests are the number of guests that were served double scoops plus the number of guests that were served single scoops. Then we have all of the guests, right? This is equal to the total number of guests. Number of guests. And they tell us that 60% of them were served double scoop. So the number that were served double scoop is 60% of the total. So that statement number 1 is just an algebraic equation. And this alone, though, doesn't help me solve this equation. Maybe in the next statement they'll tell us how many total guests there are, what this is, and that'll help me. But I don't know. Let's see. Statement number 2. Statement number 2. They say a total of 120 scoops of ice cream were served to all the guests at the picnic. So once again, they're telling us that there are 120 scoops of ice cream. They're not telling us that there are 120 guests. So let's see. What are the total number of scoops? So there's the number of single scoops, and each of those are the number of guests that got single scoops are S, and then the number of scoops is just 1 times that because they each got 1 scoop. And then you have the number of guests that got double scoops, but then the number of scoops they got is going to be 2 times that. So this is the total number of scoops, right? The number of people who got single scoops times 1, plus the number that got double scoops times 2, and that is going to be equal to the total number of scoops. And this alone isn't going to help us solve how many double scoops were served. It depends on the single scooped and all of that. But if you look at both of these statements, we have 2 linear equations and 2 unknowns. So at this point, you should immediately say, unless somehow these are, the same equation, or they don't, or somehow these are 2 parallel lines, these should intersect and come up with and allow you to solve this equation. So the answer, you should immediately, especially if you don't want to waste time, you should say that both statements together are sufficient. And if you want me to prove this to you, let me see if I can solve this. So I'll do it in a different color. So let me do some substitution. So here we get S is equal to 120 minus 2D. And we can substitute this back here. So you get 0.6 times D plus S, which is 120 minus 2D, is equal to D. And so you get, 0.6 times 120 minus D is equal to D. And what's 0.6 times 120? That's 72, right? 6 times 12 is 72. 6, right. So that's 72 minus 0.6D is equal to D. So you get 72 is equal to 1.6D, and then, 72 divided by 1.6 is equal to 45. So there we solved the problem. D is equal to 45. 45 double scoops were served, and then we could substitute back into the equation to figure out how many single scoops or how many total guests there were. But this is all that we had to figure out, and we were able to, using both statements combined. Do the next problem. 56. What is the value of xy? Okay, statement number 1. They tell us that y is equal to x plus 1. Statement, and that's not going to tell me what xy is. I mean, there's a bunch of x's and a bunch of different y's depending on what I choose. 2, they tell us y is equal to x squared plus 1. Once again, this by itself, it completely depends on which xy's I pick. Right? I can pick any combination and get different values. You could try that out yourself. But I have 2 equations and 2 unknowns. It's a little tricky because one of them is nonlinear. But let's see if we can figure it out with substitution. If y equals this and y equals that, we could set these 2 equal to each other and see if we could solve for x. So we get x plus 1, that's the first one, should equal this one because they're both equal to y. X squared plus 1. Let's see, we can subtract 1 from both sides, and you get x is equal to x squared. And let's see, you could say x, well, you could divide, if we assume that x does not if x does not equal 0. So there's two solutions here, right? X could be equal to 0. That's completely legitimate. They never told us that x isn't equal to 0. That would satisfy that equation. And then what other x would satisfy? X could be equal to 0, or x could be equal to 1. Either of those are completely legitimate answers here, right? Fair enough, right? If x is 0, this is true. 0 equals 0. If x is 1, 1 is equal to 1 squared. X can't be negative 1. Negative 1 is not equal to negative 1 squared. So these are the two solutions for x. And now so right now it seems like, oh, well, it's a little shady. But remember, we're not trying to solve for x or solve for y. We're trying to solve for x, y. So maybe when we solve for y, something, I don't know, interesting could happen. Let's solve for y. If you assume x is equal to 0, if x is equal to 0, what's y? Well, y is equal to 0 plus 1. Y is equal to 1 in this case. That's one solution. And if you put x is equal to 0 here, you also get y is equal to 1. So this is one set of solutions. And in this reality, xy is going to be equal to what? Xy is going to be equal to 0. Right? 0 times 1 is 0. Now, if x is equal to 1, what is y? Well, if x is equal to 1, y is equal to 1 plus 1. Y is equal to 2. Well, then xy is equal to 2. So, using both of the statements, I still don't know whether xy is equal to 0 or 2. Someone would have to tell me that x is not equal to 0 or x is equal to 0, and only then can I really solve this equation. So, the answer to this, even though we have two equations and two unknowns, because one of them was a quadratic and had two solutions, we actually don't know what xy is. So the answer is that the statements together are not sufficient, or E. That's interesting, because they actually kind of make you do a little bit more work than just eyeballing it and saying, oh, I have two equations and two unknowns. You've got to be a little careful when the equations are nonlinear. At least I think that's right. All right. Question 57. They want to know what 1 over x plus 1 over y. The police sirens outside. I live in Palo Alto. There's not normally a high crime scene here, but you never know. Anyway, so 1 over x plus 1 over y. So statement number 1 is x plus y is equal to 14. See, that doesn't. Well, actually, let me try to simplify this a little bit. If I were to try to add these two, what could I do? Well, when you add two fractions, you have to find a common denominator. An easy common denominator for x and y is just xy. So 1 over x is what over xy? What's y over xy? Plus, right? This is the same thing as 1 over x. Plus, and if I had xy here, what's 1 over y? Well, that's x over xy. So that can be rewritten as y plus x over xy. And now when you rewrite this statement like this, then statement 1 looks a little interesting. They gave us the numerator at least. They haven't told us what xy is, but they told us that y plus x, or x plus y, is equal to 14. So statement 1, it's kind of part of the puzzle, but it's not completely helping us. Let's see what statement 2 tells us. I suspect if this is solvable, they'll have to tell us what xy. Yep, they tell us what xy is. They tell us that xy is equal to 24. So then we're done, right? This simplifies to this, and they're telling us what this is. X plus y is 14, so it equals 14 over 24. Not that we have to really solve for it, but that is equal to 7 over 12. But as soon as you say, oh, that's that, you're done. You say, both statements together are sufficient. So C. 58. If D denotes a decimal, is D greater than or equal to 0.5? So there is D greater than or equal to 0.5. They put a 0 here, so you make sure you notice the decimal. D greater than or equal to 0.5. Statement number 1 tells us when D is rounded to the nearest tenth, the result is 0.5. When it's rounded to the nearest tenth, the result is 0.5. So let's see. It could be, this could be 0.52, and when you round it to the nearest tenth, it becomes 0.5. But on the other hand, it could be 0.46. And when you round it to the nearest tenth, you also get 0.5. So since statement 1 says it could be either one of these, it really doesn't help us know whether we're greater than or equal to 0.5. This one is greater, this one isn't. So statement 1 by itself doesn't help. Statement 2. When d is rounded to the nearest integer, the result is 1. Now this is interesting. If something is rounded to the nearest integer, it has to be greater than 0.5, right? I mean, the smallest number that when you round it to the nearest integer equal to 1 is 0.5, right? So it has to be 0.5 or it has to be 0.51. Because 0.499999, when you round it to the nearest integer, is going to be equal to 0. These have to be, that's the only way you can get rounded to 1 if you're 0.5 or above. So actually, statement 2 alone is all you need to know that d is greater than or equal to 0.5. So that is choice B. Statement 2 alone is sufficient. I've realized I've run out of time. See you in the next video.